Here's a really neat project, again, that I did well before my YouTube time. In fact, I'm lucky to even have documentation on this. I wasn't so great with my documentation way back when I was taking pictures, but this one here was a pretty large project, so I figured, maybe I should, document this, and I'm glad I did, because now I can share this with you just in picture form. I can't even imagine how much video editing this would have been if this was a video. The amount of work that went behind this and all the different circuit boards that I built to put inside this was incredible. So let's start with what it is. So for any of you that own one of these things, right now you're probably looking at this going, wow, I really want mine to look like that. This is a Sony CRF230B communications or radio receiver with the FM band and also, beat frequency oscillator and all that. You see the 3 antennas on the top. Really, really hot receiver. So whenever you hear the term hot receiver, that means that it receives very, very well. So if somebody ever says, oh, I own this receiver, it's a really hot receiver, that means that it's a very, very sensitive receiver, works very, very well. And that's exactly what this is. So I spent a lot of time rebuilding this thing and put lots and lots of time into this thing. This goes well beyond the Sony CRF 320. I think that I've done 320s, 330s, Sony CRF V21s. I've done the 6800s. I've done the orange. I've done all of them. I've done so many of these radio receivers. It's not funny. So the numbers, they kind of blend. So pardon me if I mention a wrong number as I'm going through this. But this is the Sony CRF 230B. So in the next picture over here, you'll see the display in this thing lit up. So you'll see how that each display is lit up red, and then the one that's of interest that you're listening to is lit up green, so it's highlighted green. So if you were to press the white button next to that, of course the previous button would pop out, that green display would return to red, and the next one would go green. So it highlights the one that you're listening to. Well, the factory display in these radio receivers is really dead. It is just a really, really gloomy look to it. It had incandescent bulbs behind them, and the incandescent bulb would only light up on the band that you wanted to listen to. So all the rest of them remained black or dark, and then just the band you're listening to would light up kind of a dull green color because they had an incandescent bulb in kind of a plastic square light pipe, which I'll show you here in a moment, with a green film over top of it. And it got even worse if it was on battery power. You had to press the little light switch below the S meter. So on the left-hand side of the radio, you'll see the S meter. Right below that, right beside the little glowing AC lamp, you'll see a little light switch. Well, it's a spring-loaded switch. So when it was on battery power, nothing lit up. Okay, so you had to press that down to see the band and where you were if it was dark, and then let it go, and it would spring-load back into the off position again. So really kind of a dull, bland, of course, it's the technology of the day, right? In the next picture over, you'll see the whole unit is taken apart, and you'll see all the black film there. So that's like a camera film, and it rolls. When you tune the dial, that film rolls up and down. So the pointer or the indicator line stays steady, and the film rolls back and forth, somewhat like a Racal receiver, which was going to be in the Grand Receiver Restoration Series, which is going to be on this brand new desk, which you will be seeing here in the next little while, along with R390 and all these AR88 receiver and all that great stuff. Anyways, in the next picture over, you'll see the three windows. So this would go in the center of the radio. So where you saw that one green dial lit up and the other two were red, well, that would be the windows that was sitting behind it, and that would shine the light into the back side of that film in order to light that up properly so that you could see the dial. So really dull. You can kind of see, like, Sony did a really good job. Their engineers are very intelligent. Even in the light pipe, they really thought of this. You can see there's kind of lines in the actual plastic. So you see the green film, and then there's lines in the plastic below that green film, and that carries the light very evenly over those squares, even with a dim incandescent bulb. So here's the back side of the unit. You can see the black and white wires running into each incandescent bulb, and each one of those little boxes is very reflective on the other side, just like you see on this side here, to further reflect that incandescent light. And it really made it quite even, but very dim and dull looking. So I'm thinking to myself, how can I improve this? So in the next picture over, you'll see that same display, but you'll see 4 leads sticking out of each box. Well, those are high brightness RGB LEDs. In the next picture over, you'll see one of the circuit boards that I designed. And that fits right down on top of that board. Those leads poke through the top portion of the board, so those holes that you see are drilled. And in the next picture, you can see it's soldered directly to the back side of the display. So the back side of the circuit board, now the amount of designing that went into this was really quite extensive because this is a single-sided board and I had to make all these ICs work without any jumpers on the other side of the board. This is all a single-sided board. The back side of the board is solid plated or tinned copper. The reason it's like that is for shielding, for number one. And number two, I can solder them anywhere I want on the backside of those boxes so I can make everything work out. I only had so much clearance. The ICs, the little integrated circuits and those tantalum capacitors that you see are probably a couple of millimeters away from the back. So everything was very, very tight. I even had to, play with the thickness of the printed circuit boards. I got very, very thin printed circuit board to get all of the space that I could, so that I could fit this back in there. And this completely hides behind the display. You can't even see this has been done. So I wanted this to be as, I guess you could say secretive as possible. Now, when I design things, I design things to not fail. Okay, so I put the time into this, and same with everything that I do. All the LED lights in this thing are run at basically a quarter or below current. Okay, so they're high brightness, so the brightness that they have at even a quarter of their current is bright still. This way you get maximum life out of the LEDs. In fact, they basically never go away, and you don't have to go worry about replacing them again. And that was one of the big issues with this radio receiver, is because getting in behind these displays to replace burnt out light bulbs was a real pain. So this never has to be done again. And there's a whole bunch of perks. So in the next picture, you'll see another one soldered onto a different display with some of the wiring, the ribbon wiring. The two little wires that you see are the trigger wires from the switch to tell which one to light up, all right, to which one to highlight. I guess you could say you see SW and SW, that stand for switch and switch. That would run down to the little switches, and that would tell this particular unit which one to highlight. Now, in the next picture is another board. So this is the next board, and again, you see the little SW, the switch line, all right, that goes to the switch, tells this one when to highlight and when not to highlight. And you can see all the wires and the leads that need to carry through, L, B, plus, and I, and that has to run through to each unit on that 4 ribbon wire, kind of runs in parallel to each one. Now, keep in mind when I designed this is inside of a radio receiver. It's a communications receiver. So there can be no noise. So this is all DC. There's no pulsing running at all. It's perfect DC, dead silent. And when I say dead silent, I mean dead silent. The receiver is a great receiver. Nothing can be compromised in this. It has to operate just the way it did from the factory. Anything that's an improvement is an improvement with nothing taken away from the receiver's performance. And that's what I did. In the next picture over, you'll see the control board. This is the top side of the control board, a little heat sink on the top there, and filter capacitors. The two little VRs that you see by the capacitors there are to adjust the variable brightness for 2 of the levels. And I'll explain that here in a moment. On the next picture, you see the back side of the control board. So this is the other side of that same board with the ICs on the bottom. Next picture, you can see it's all coming together. All the displays are coming together. You can see a ribbon wire poking out of there, and one of the wires that runs from display to display to display. Now, in the next picture, you'll see one is lit up red, and all the rest of them are lit up blue. And in the next one, you can see I've pressed a different button. You can see how all the other ones are blue, and now the highlighted one is red. But if we look at the next picture, you'll see all of them are red, and now one is blue. So it's inverted. The display's inverted now. Well, you can do that all with one button, all with that light button right below the S meter. Just by holding it and pressing it for different amounts of time, you can invert the display. You can change the colors from red to green to a sky blue, not that deep blue that a normal blue LED has, but it changes it to a sky blue, which is a blend of green and blue together. So you can change all of these different colors. You can change the displays to all these different colors. And then if you would like, you can even invert the display to do the opposite. By holding that light switch for different times, you can dim the display in 3 different steps and even shut it off if you want. All with one spring-loaded switch, just with different techniques of holding it down and for different times. Just an incredible amount of work went into this thing. So, if I ever get another 230B, I'll consider it, because I have all the boards designed. I just have to, print them off and populate them. I'll consider it again, but again, the time is pretty high. I teach an electronics course on Patreon right now, and I'm in the beginning of a brand new portion of that course. It's how to fix just about anything electronic is the course, and it's just beginning right now. And there's a lot of time being put into that. I'm walking people through building circuits and troubleshooting and showing how to use test equipment and things like that up on Patreon. So I can't imagine trying to fit a project like this in with doing all of that I wouldn't have enough time to eat or sleep, which is basically my life anyways. It would just be less of each. For those of you that have been on my channel for any length of time, you'll know with electrical work and everything, I'm usually pretty hard on myself. I'm pretty picky about my own work. It has to be done just so, or it's not good enough. And this amplifier would be a very good example of that. Everything had to be electrically matched and mechanically and aesthetically uniform. So lots and lots of work went into this. In fact, I ended up, I guess you could say, tailoring this amplifier around some speakers that I had at the time. There's a lot of work around Stanford Research SR780 and monitoring mics and all sorts of stuff in order to make this amp do just what it does. So the whole idea of the amplifier was to have little or no feedback with as little distortion as possible. So I gave it both. So it does have little feedback and no feedback. And I'll get more into that here in just a moment. Now, when you look at the front of the amplifier, just below my name, you'll see a little indicator light on the front. You're probably thinking that's just an on light or whatever, but that light actually means something. So you see how it has a little 0 lit up in there? That means 0 feedback. So in this mode, there is no feedback. There's a switch on the side that you could click, and the 0 would go out and a little dot in the center would light up, and that would mean that it had feedback. Very little bit of it, but it did have feedback. Now, in order to get low feedback out of an amplifier design like this, it's a pretty, I guess you could say, radical design. In the front of the amplifier, you'll see a bunch of tubes. There's 4 tubes. They have Sylvania written on the 2. You can see that there. And the other side, they're the same tubes. Those are 12 SN7s, not 6 SN7s. Not for any reason, just because I had a lot of 12 SN7s, and the transformer in the back has many 12-volt supplies in it. So I used 12-volt heater tubes there, and it's rectified as well, so it's on DC. The plate voltages inside this amplifier are really elevated. Again, because you want to get as little distortion as possible with no feedback, right? So to give you an example, the 12 SN7s have got positive 300 volts on them and negative 300 volts on the cathode. So there's 600 volts across those tubes. And the filaments are isolated to minimize heater to cathode shorts. And I've never had one yet, so they work very, very well. Now, the 2 little tubes that you see in the front, they say Westinghouse on them. They're closest to the front of the amplifier there. Those are current sinks for the phase inverter, so that I can keep the amplitude of each phase, they're 180 degrees out from each other, right? So I can keep the amplitudes very well matched, again, for low distortion. So the system is so sensitive that you can tap those tubes with your finger and you can actually hear it go ping, ping in the speakers. That's how sensitive those little current sinks are in the front there. So if it sits on a relatively solid device like you see it is on right now, it sits very, very quiet. All of the heater voltages, everything is all rectified, aside from the RK39s, which are in the back. Again, I'm using RK39s because they handle elevated voltages quite well, hence the plate caps on the top. The large tube that you see in the center of the chassis is a 6AS7. That's the positive 300 volt regulator, so that's a pass tube. And right behind it, so you can see between that very small tube on the front of the chassis and the 12SN7, you'll see a tube kind of lit up closest to the 12SN7. That's the control tube for the actual 6AS7 or 6080 if you like. Beside those, you'll see another bunch of Coke bottle style tubes, and they have kind of a purple glow to them. Those 2 tubes are the negative 300 volt supply shunt regulators. If you look at the RK39, so those are the tubes with the 2 white bases, the large power tubes with the plate caps. If you look on the right-hand side, if you look right at the base, you'll see a tube right between them, far back beside the power transformer. That's one of the reference tubes for the 300 volt positive supply. On the other side of the transformer is another one of those tubes. So there's 2 references for the 300 volt supply. So the negative is just a shunt type, and the positive is very, very well regulated. Now, I still have the schematic in my head. I never really drew a schematic for this thing, and in order for me to display that to you, I'd have to sit back and draw up a schematic, and I may just do that down the road. The amplifier sounds nothing short of fantastic. So very, very quiet. Sits very, very, very quiet, and it produces quite an amount of audio. Works very well. So the picture next to it here, or the next picture I should say, is me just getting ready to cut holes in the chassis. And just me measuring things up. I moved some things around. I wanted to have the filters on the top, and I decided to put them on the bottom on circuit boards. You'll see that here in just a little bit. Next is the chassis, basically drilled and ready for tube sockets and jacks and power cords and all sorts of things, and feedback switches and all that. The next picture over is the transformer that I used, the main power transformer. So I preserve Tektronix oscilloscopes. I don't destroy them. And there was a fella local to me here that wanted all the tubes out of a bunch of Tektronix oscilloscopes, and he absolutely destroyed these tech scopes, and this is all the stuff that was left. So this isn't even out of my collection. This is just a bunch of random. I bought, I think it was 3 or 4 power transformers off of him, and a bunch of chassis that were just gutted and things like that. So rather than see these power transformers go to waste, I put them to use. So yeah, definitely, that power transformer is not from any wrecked scope that I own. So I had to save it. So I used it in an amplifier, and it worked quite well. Lots of nice supplies on there. You can see all the wires on the bottom. In the next picture, you can see the power transformer mounted to into the actual chassis, and there's a stabilizer, almost like a bar across there, because the power transformer is so heavy, it actually kind of caves in the top a little bit. So that stabled things up, made the chassis really quite rigid. You see all the holes there. In the next picture, you can see one of the circuit boards designed, and all the tube sockets are installed, and you can see the power transformer, the wires are cleared off at that time, and that's ready for wiring. In the next picture over, you can see one of the circuit boards that's for, this is just one of them, that's the other side circuit board. Again, a lot of these pictures are just pictures I found. So some of them are, I think I accidentally slipped one file into another, and I have to go looking through all my files to find the rest of the pictures, but this is what I have for you right now. So that's one of the boards there that has to be populated. And then in the next picture, you can see the 2 feedback boards that sit right at the front of the amplifier. So there's a relay that sits right in the center. And when you click a switch, it clicks in the feedback, and it eliminates the feedback. And in the last picture here, you can see it working on one of the stands. Now the speakers you see there are actually run off the amplifier that's beside it down on the bottom there. That's another amplifier that I designed. It's all gold plated and a powder coated chassis and all that down at the bottom. So a different type of amplifier. But this one here is powering the speakers, oddly enough, that are not even in the picture. They're off to the side a little bit. And so I was listening to those speakers at this time. So that's the amplifier in use there. Maybe down the road, I have very few pictures. The amplifier that you see on the bottom, or the gold-plated one, was in a time before digital cameras. So basically film cameras. I probably have a packet of pictures that I could maybe scan into a computer. Maybe I can share some of that with you as well. So that one was a very extensive design as well. You can see down there, there's 4 6L6s per side. Those are GCs. And a relatively common design, phase inverter drivers, the phase inverter, and then in the center just one stage of amplification. Sounded very nice. The lab is coming together. Lots more equipment in here, and I'm running feed lines and coaxes and all sorts of stuff into this lab, so you can probably see some lights behind me lit up that you haven't seen lit up before. So things are coming to life here. Again, this is all being done so that I can make more videos, and I also want to get into this grand receiver restoration series as well. Lots of stuff coming, circuitry design and repairs and restorations. So if you haven't subscribed, now would be a good time to do that. Oh, and let me know you liked the video by giving me a thumbs up. If you'd like to take your electronics knowledge to the next level and learn electronics in a very different and effective way, I have a brand new electronics course going on up on Patreon right now, and it's titled How to Fix Just About Anything Electronic. So it's a very in-depth training in order to show you how to look for certain failure points and how to use your test equipment, and basically how to diagnose dead circuitry and become the best that you can be. So definitely check that out. That's on Patreon right now. I'll put the link just below the video's description, and I'll also pin the link at the top of the comment section. That's the only two places I will put the links. So click on either one and it'll take you there, and you can check that out and join the group. Right now there's about 150 plus videos up there. So that's at the date of this video. There's about 150 plus videos up there where I'm sharing my inventions and designs, and lots and lots of different topics that you can look at and choose from. So you can choose whatever you're comfortable with and learn at that level. I'm trying to make it universal for everyone. Again, if you've been on my channel for any length of time, you'll know I'm very, very picky and very accurate about things. So I'm trying to fit everything in for everybody here. So just trying to make the electronics community come together. Let's basically look at it like that and share as much knowledge with you that I possibly can. So that's my goal here. At any rate, hope you enjoyed, and I'll see you all very soon. If I don't have another video out before Christmas, I wish you all a very Merry Christmas or Happy Holidays, whatever makes you happy there. And I'll see you all very soon. Bye for now.